Let's start with a few simple questions. What is NDI analysis and why should you care? Well, NDI analysis is a command line tool for Windows designed to provide detailed diagnostics about any NDI stream on your network. It doesn't show you the picture. What it does show you are the numbers, frame timing, data rates, packet consistency, resolution changes, and more. Now, here's what's important to understand. NDI analysis does create a full connection to the source. It receives the audio and video stream just like any NDI receiver. That means it uses bandwidth, and depending on the stream quality, it can also load your system's network interface and memory bandwidth. It doesn't decode the video, so it won't stress the GPU or CPU as a playback app would, but it does actively process and measure the incoming stream in real time. So it's not a passive observer, it's a full participant in the NDI network. So why would we use it? Well, because in the world of NDI, everything might look fine until it doesn't. Your video might stutter, your audio might drift, a stream might randomly fail to connect, and when that happens, NDI analysis helps you to answer the hard questions. Is the stream even arriving? Is the frame timing stable? Are packets getting delayed or even dropped? And is the transmitter sending at a consistent rate? This tool is a must-have if you're building an NDI-based production environment or troubleshooting a difficult-to-understand problem. Let's say you've just walked into a studio and want to see what NDI sources are available. You don't need to launch a monitor app. You could just run this command. At this point, the application scans the network and then it returns a list of active sources. It tells you the source name, like Studio Cam 1 or Scan Converter V2, and so on. It tells you the host IP address, which port it's using, and you can even set a custom timeout with the /time command option. By default, NDI analysis will only locate sources in the public group. To find sources in other groups, you can specify them like this. Now let's say you've found the source that you want to investigate. Maybe you suspect it's dropping frames. So here's the basic command, but now we want to limit the analysis to just 1 minute. Now we might want to test a low bandwidth version of that stream, so we can use a command like this. And if we need the video only, we can change the command like this. Or we might just want audio, in which case this is how we might change that command. There's also this command, which is great if you suspect something's wrong with the stream encoding, like missing frames. Now let's dig into the most powerful part of NDI analysis, the timing metrics. When you analyze a stream, the tool gives you 2 key values that look like this. These lines contain everything you need to evaluate the health of your NDI stream and, most importantly, to determine when things go wrong. The video received value is the frame arrival at the receiver, and it's a value that shows how the receiver experiences the stream. Even if the sender is perfect, network issues can wreak havoc here. Now you're aiming for an average value of around 16.66 millisecond for a 60 frame per second video. And an example like this means that the timing is fairly stable. The ±2.50 is jitter, the standard deviation of the frame interval. Now, the lower this is, the more consistent the delivery. A variance between 8.34 milliseconds is typically reliable. High maximum times, for example 150 plus milliseconds, will indicate dropped frames or network congestion. And it's also worth noting that some NDI sources, like the scan converter, may also skip frames on purpose if nothing is changed on screen, for example. The video send describes the frame delivery from the transmitter, and this value tells you how the sender is performing before the data even hits the network. If the send jitter is high or delivery intervals vary wildly, the sender might be overloaded or struggling with encoding or maybe even underpowered. If the send values are clean, however, but the received values are messy, well, then the issue likely lies in the network path itself, congestion, misconfiguration, or packet loss. And for a deeper analysis, really you should refer to the official NDI Analysis tool documentation.